Basically, you have a function where t is in years, and for any time t, you get the population of fish at that time t. So basically, t of p of 6 when t equals 6 is going to be about like 1400, 1500, I don't even know, somewhere around here. The question is asking is which gives the best estimate for the instantaneous rate of change of p at t equals 4. So basically, what you need to find is first we need to know that the instantaneous rate of change. Okay, this is the same thing as slope of tangent line. And that should make sense because the average rate of change is the slope of the secant line. So basically, like to illustrate this point, here at 2 years, the fish there's some population of fish. And then let's say at 4 years, right, there's also then another population of fish. If I wanted to find out the amount of change, right, over those 2 years, right, I would do, right, the slope of this line joining these 2 points. It's the slope of what's called, this is the secant line. Secant line. Okay, slope of secant line. That's this line right here. Well, that is the secant line, and if I wanted the average rate of change, again, the average rate of change, the rate of change from 2 years to 4 years, I would find the slope of this line, because you would find out how much it changed in y, right? Like, let's say this is 10 down here, I don't know, maybe it's 10. I would find out how many fish increased, right? And I would do the 250, the y value for this point right here, right? This point right here is 4, 250. And then this point right here is 2, 10. And I would find out how much changes along the y, how many fish increased, right? 250 minus the 10, over the change in time, which is 4 minus 2, which is exactly the slope of this line. y2 minus y1 over x2 minus x1. And that would be the average rate of change of the fish population over 2 years, over these 2 years, from 2 to 4 years. Now, if we think about this, right, let's say I wanted to find out the instantaneous rate of change. Okay, let's say I wanted to find out exactly how many fish, or exactly how many, exactly what the rate of change is at let's say 2 or let's say 3. Let's say that this is 3. I don't know. Okay, I want to find out exactly what the rate of change is, the instantaneous rate of change. It should make sense that that's going to be the slope of the tangent line, because let's say I did the slope of this secant line. That would be the slope of the secant line between 2 and 3. That would be the average rate of change between 2 and 3 years, or that in that 1 year period. But if I want an instantaneous change, that time period shortens, right? The instant it goes like that. The instant is instantaneous. So you want to take shorter or smaller and smaller intervals, or shorter and shorter time periods. So like 2.5, right? If I found the slope of this secant line, that would be a better estimate for the instantaneous rate of change at 3 seconds. So like if I got even closer, right, and I did 2.8 and 3, right? Let's say this is, I don't know, 2.8, and let's say this is 3. The slope of that line is very close to the slope of the tangent line. And that gives a better estimate also, right? The average rate of change between 2.8 and 3 is close, or closer, to the instantaneous rate of change at 3. And you just basically keep making this interval smaller and smaller. And what you're doing again is that you're shortening that time interval closer and closer to an instant. and that gets closer and closer to the slope of this tangent line. So when they ask this question, right, which gives you the best estimate for the instantaneous rate of change of p at t equals 4, you want to find the one that's going to give you the closest, the shortest interval between for 4, right? So like the shortest interval, right, that they offer, or the shortest interval that you might be given is, let's say, 3.9, and then right next to it over here is 4.1. Okay, and the slope between these 2 points, if I'm very careful and I go up, right, would be, this is the point on the graph that's this point right here, right? I don't know what the y value is, so I'm going to write it in terms of the function. I'm going to write it as 3.9 comma p of 3.9, and then this point right here is going to be 4.1 along x, and then p of 4.1 along y. And that's going to be very close to the slope of this tangent line. If I connect those two in a straight line, I mean, you can see that it's very close to the actual line, that line right there. And I'll even try and make it a little bit more accurate, something like that. And that blue line is very close to that black line, which is representing the slope of the which is representing the tangent line. I apologize. This black line is the tangent line. And then this blue line that connects these 2 points that I did is very close to the actual tangent line. So its slope is very close to the tangent line. If I pick points further away, this would be less accurate. If I did, let's say, between 0 and 8, okay, let's say I use these 2 points, this secant line joining these 2 points. Let's say I do it in a different color. So let's say this point right here, and then this point right here, and I join these 2 points with a straight line. And you'll see it's not very close to the actual tangent line. So if you look at this, right, that line, it's somewhat, but that's just more or less coincidence, really. But the blue line is definitely closer to being the tangent line than that orange line. I mean, in theory, and again, just getting close guarantees that it's like the tangent line. So we use these. You want to use an interval that's as close as possible, and that is your answer. You want to now use these 2 points, and this is going to give you the best estimate. You compute the slope of this blue line joining this point right here and this point right here. So the slope of that blue line, make sure we know, right? x1, y1, x2, y2, right? Slope formula, y2 minus y1 over x2 minus x1, right? And now for this line, the slope of this secant line, y2 is p of 4.1 minus y1 is p of 3.9 over x2 is 4.1 minus x1 is 3.9. And this will give you the best estimate for the instantaneous rate of change of p at t equals 4 seconds.